All right, at long last, we come to the end of chapter 4. This is all about, obviously, coordinate geometry. And if you look at that list there in the panel, we've done all those things. And we've been dealing with Voronoi diagrams recently. I know that getting away from the network of perpendicular bisectors and actually committing yourself to draw the Voronoi diagram, those certain line segments from the perpendicular bisectors, can be a bit daunting. It just takes practice. We're going to practice a little bit more today. And we're also going to take a look at an application. One of the reasons why people are interested in Voronoi diagrams is for spatial reasoning problems. You'll see what I mean in a couple minutes here. Let's take a look here. Okay, so again, just going to keep on hammering away. The ordered pairs that start this all off are called the sites. You can see that we no longer join them with line segments. The actual triangle joining A, B, and C, it's irrelevant. Sometimes we'll put them down. I'll put them down because I like to see it in contrast to the perpendicular bisector, but then I tend to remove them afterward anyway. Where those perpendicular bisectors meet is referred to as a vertex. And those regions that the boundaries sort of delineate or carve out are called cells. Okay, let's take a look at now. Two big applications today. Before we get going, I'm going to start with one more diagram. There's 4 points A, B, and C. You start off with 3. And then after you've got your 3-site Voronoi, then you add the 4th one in. Otherwise, it becomes a bit too much to do at once. Now you can see that even though I've drawn the 4th point D, I'm not using it entirely at the beginning. So I've got my points A, B, and C, and I've drawn the perpendicular bisectors to that. One of the students in the class reminded me that you can actually draw a perpendicular bisector without the line segment itself there. That's fantastic. If you need help with that, make sure you ask me. I'm more than happy to come and show you how you do it on your graphic display calculator. So what do? I'm going to consider the vertex, which obviously in my mind is going to have to be, that middle point there. And I'm going to radiate out. So the line that divides A and C, I'm going to start at the vertex and go toward splitting the space between A and C. I'm going to go back to the vertex, and if I'm thinking about, knocking out the space between A and B, I go out of the line that separates A and B, and then lastly, the one that goes through B and C. If there were more perpendicular bisectors somewhere, I would reflect on what we're doing when I reached it, traveling along one of these lines, and that's how the Voronoi is going to emerge. So I've got this sort of temporary Voronoi diagram now. Okay, now D, we're going to have to consider D. You'll see that there's we got a line that would separate them there, and then D would get separated from C around there, and obviously any 3 that are supporting the same triangle always connect at the same spot, called the circumcenter. So that's what I'm going to end up with, but I'm going to draw the actual perpendicular bisectors in there now, and sure enough, they do cross that red line. And so once I go back to this spot, I got to decide on how am I going to split B and D. I go off in a way that I split B and D up. So it's going to be that one, and then I got to go the other way there. And that's it. We've added it all in. And that is our Voronoi diagram for those 4 points. I grabbed this from a rival textbook for the Applications SL course from Pearson Publishing. And just look at my answer, then look at their answer. And it's exactly the same. Okay. 2 things we're going to be doing today. One is called the nearest neighbor interpolation, and that is when you're trying to find out when any given point that's not part of the Voronoi diagram, which site is it nearest. So what we're going to do is we're going to take a look here. Here's an example. Someone has bothered to look up the amount of rainfall that happened on one special day, July 27th, 2017 in Pueblo, Colorado. And you can see that measured in inches, there's the rainfall over a certain grid space that they've measured out. And they got this point P down here, and we want to know what we should approximate the rainfall to be. You can see that some sites that are nearby have got rather disparate amounts of rainfall. So which one do we assign to it? Well, whichever one's closest. In order to do that, I'm going to go ahead and find a Voronoi diagram. Now, some of you would probably realize, as you're looking at this, what do we got? We got 2, 4, 6, 8, 9 points there, and I don't want to find a 9-point Voronoi. That's going to be crazy. So I'm just going to use the ones that are nearest point P and exclude the other ones. So what it means basically is we got point P at 6, 4, and I'm going to look at those points that are quite nearby. I mean, there's no chance that anything up here is nearer to P than one of the 4 that I highlighted there with those small red circles. So what am I going to do? I'm going to make a Voronoi just with those. It starts off by identifying the coordinates because I need to use those on my GDC. So here we go. Let's go over to the GDC and take a look at this thing. Now I've graphed the first 3. That's this one here. I've called this one B. I've called this one A, and I called this one D because I had already called this one C earlier on. It's not like why to go A, B, D. It's just because I already had C down, then I removed it because I thought I'd go with those 3 on the left first. So I've got the 3 perpendicular bisectors, and they obviously do meet at a certain space there. So I go and I fire off lines between the 3 points there. And that's what I come up with. Now, after I've done it for 3, I bring in the next point and I connect it with perpendicular bisectors that are nearest the other site. So nearest to I wrote the one in for A, but I think it's kind of meaningless. I don't think this line here is going to have any role to play. I think my Voronoi is going to actually end up doing something like this, and this point is going to, that line is going to shrink up. Anyway, so there you go. And when you put it all together, you get that. Take away the other excess dots that you don't need and excess lines. And so if I now enter the point P64, that one it said earlier its coordinates were 6, 4, you can see exactly which point is nearest. That's called the nearest neighbor algorithm. And when you have it, we can simply say, well, it makes the most sense, short of any other evidence, that we should attribute 0.63 inches of rain to point P as well, as opposed to whatever rainfall was recorded at sites A, B, and C. Okay, and now here's the final part of the entire chapter, which is called the largest empty circle, sometimes known as, not terribly surprising, LEC, for the acronym of largest empty circle. What we're going to do here is we're looking at, sometimes it's known as the toxic waste dump problem, because we're looking for a spot on a map after it's been Voronoi diagrammed, separated into its pieces. Where is the place that is farthest from any of the sites? We presume that those sites might be villages or just, places where people live, and something is quite scary as a toxic waste dump. You don't want someone in someone's backyard, so you want to get it as far away as possible. And that is an application of what we call the large circle problem. We're looking for, you'll recall that when you've got 3 perpendicular bisectors, what they are doing is they're separating sites. And what I said earlier in the chapter is there is a circle that connects those 3 whose center is at the vertex of the perpendicular bisector. So what you're doing here, you're trying to find the largest empty circle. You're trying to find which vertex, because this is not a site. It's not where the people are. The people are on these sites that are here on the edge. You want to find the spot, like this one here, which is furthest away from all the other dots. In essence, you're looking for which sites are furthest from its supporting vertex as possible, because that would be the location of that awful thing like a toxic waste dump. On a different note, supposing you're an entrepreneur and you want to open a restaurant like it says here, and you want to compete, obviously, and be better, but on the other hand, it wouldn't hurt if they're not like right on your doorstep, so you might want to go far away. Now what you do is you look for the vertices of ones. I can see this is a rather largish zone here where there's nothing going on except those lines. So that means that one of these vertices is going to be further to sites than any other spot. Certainly if I was to draw one here, it's quite near to J and N, certainly nearer than this point is to B. Now how do we actually find that? Well, you can see here that we would nominate a couple points, find their coordinates, and then just check how far away is it from the sites in the neighboring cells. Okay, so here's an example. Use the Voronoi diagram to find the center and radius of the largest empty circle. So I'm going to take a look here, and I notice that the distance from V, and that's a potential spot, it looks quite far relatively to these. Obviously they're going to be exactly the same distance, and if I were to go to any other of these, it's confusing a little bit because you can see that the coordinates are presented for the Voronoi vertices, but also for the sites. You got to keep them quite clear. We're talking about which vertex is farthest from its supporting ones. Now you can see from this point here, y over to e, that's only like 2.5. So I don't think that's going to win. This appears to be much more. So what you do is you take a look at point E, and then you look at all of the neighboring ones here, and you check it out. So what we have is we check out from V, the distance to its neighbors, which would have been potentially E. E's coordinates are 11. Yeah, you can see they worked with E. You can check out W, all these ones here, and you can see that the distance from V or W down to E is the biggest of all of these numbers here. And so therefore, that is the furthest away that you can get. If you put your restaurant either at W or at V, you're as far away as possible from that other restaurant there. Now, if you had a larger Voronoi already completed and you were asked to add a bank decides to add a branch at the point H, which is 66.28. So I'm going to go, let's see, that's 66 there, 28's about there. So I'm going to go in around that neighborhood, approximately there. Oh, don't want that. So what am I going to do? Well, I'm going to cut out some perpendicular bisectors between it and neighboring sites here. And that's going to have an impact on those other lines. You can see here that when you do that, that's exactly what's happened. It's carved out a new space. And that's how you would add it, by adding the perpendicular bisectors and then working your way in and comparing it to the three nearby ones. It then said you wanted to find the distance. Well, you can go ahead and do that there. Take a pause on the video and try it for yourself and make sure. Okay, so where does that leave us now? We've done absolutely everything that you're asked to do in this section on Voronoi in the space and shape Cartesian plane chapter, and this is a seminal moment because we've just finished chapter 4. There's that's good stuff, and that's all the Cartesian stuff: midpoint, distance, equations of lines, perpendicular, parallel, and the big applications, which is Voronoi. Okay, so let's take a look here just to make sure that there's nothing we haven't done. Yeah, got it. Very good. Some of you may want to consider Voronoi diagrams for your IA. There's a lot of interesting applications there. Mathematics isn't that tough. It's just you're going to make a nice, thorough project. Now, here we are. We're at the end. Now, previous video, you've seen you've already been asked to do those questions, so I guess we're done. Well, yes. But there is this one question in the revision set that I think you should try. It does a lot of things, including that largest empty circle and the toxic waste dump problem. It gives you, some points here. It's really quite a nice little question. Well, nice little about it. Quite a big question. I think it's worthwhile, and you should always be trying. Obviously, we're using more Revision Village for our test prep and past exam questions. So this is a nice selection of questions at the chapter review section at the back that you really want to be taking a look at as well. So there's that question right there. You can just read it from the screen right here, or you can take a look at the end of chapter 4 and find it for yourself. Right, that's it. Chapter 4 is finished. Congratulations on that. And I'm here. Make sure that you pause the video a lot of times and make sure you know how to work your GDC to make those magic things happen, okay? All right, we'll talk soon.